And I'm live. That is pretty cool. Today is 4th of April 2026, Saturday. And let's just start solving some problems. And yep, there are these problems which I have already put here in review to solve later. These are the problems which either I was not able to solve or like I wanted to resolve. So we'll be doing these. But before moving into this, it has been a long time since I solved any DP problem, so let's solve a DP problem. This one I did solve this at some point last year, and this is actually like 1200 rated, pretty simple DP problem. Let's solve this one. This one was on GitHub, not on GitHub. This one was on Discord. Someone said that they were trying to solve this, but they were not able to solve this. So let's solve this now. So the problem is this. We define that a block is an array where all elements in it are equal to the length of the array. For example, 3, 3, 1, 1, and 4, 4 are blocks, while this and this are not blocks. So this means they have given a term called block, and they call blocks arrays where the number of elements in that array is the value of each element in that array. Here in this array, the number of elements are 3, and each value in that array is also 3. So that is a block. In this, the number of elements in the array is 1, and that element itself is also 1. And same here, the size is 4, and each element is also 4. But that is not the case with this. So with that definition of a block, an array is called neat if it can be obtained by concatenation of an arbitrary number of blocks, possibly 0. Note that an empty array can always be neat. So after they have defined what a block means, they are saying if we have a bunch of these blocks and we put them together in a sequence, we call that new array neat array. So okay, we know what a block means, we know what neat array means. Now you are given an array A consisting of n integers. Find the length of the longest neat subsequence. This means that here we have been given an array and we have to find the length of the longest neat subsequence. Wait, should subsequence or subsequence? C is a sequence of A if C can be obtained by deleting of several from arbitrary positions. Okay, that is crazy. Yep. So this means we have been given an array and we can remove some random elements from wherever we want from throughout the array, and the final thing that we get, the final thing that we get should be a neat array, and we have to find the longest neat array. For example, in this case, we can remove this 2, and then we will have a neat array where we have one block of size 1, which would be this one, then one block of size 3, and one block of size 4, or one block of size 1 again. So that would be 5. Size of this thing would be 5. 5 is the answer. Cool. Shit, I thought we had to find the not a subsequence but a sub array. That is, we can just take a continuous block of elements, but we can remove anything from anywhere, and we have to find with that the best neat sequence. Okay, cool, cool, cool. Let's do this. Right. Hmm. One plate. Yep, presetter is also working. Yep, cool. New Vim presetter broke, but now it is working, so that is pretty cool. Okay, and 8 spaces. Shit. Podium. Toggle. Cool. Podium is disabled. Now we are going to get n vector A size n for int reference x in A take into x and okay vector answer size n 0 at each position. We will ask a question. For example, let's take this example. In this, yep, at each position we will create another array called res or answer or whatever, and at each index you would have the best possible answer in this subsequence. So let's say we want to include this. We are here, so we will need to know the best possible answer for this subsequence. For this subarray, what is the best answer in this? And then, since either we include this digit into this or we don't, there are only two possibilities. So if we do include 3 into this, we would have to remove 1 and 2, and we will get this, like this sequence of 3's, 3 3 3. So we'll get 3 elements out of this, and apart from that, the best answer from this remaining subsequence or subarray at the start, which would be 0 because there is nothing here. Or I guess a better way to put this thing would be, we need to find the best subsequence in this that is neat, the longest subsequence among this, which is neat. So if we just solely focus on this one digit here, and there are only two possibilities: either 7 is a part of the final subsequence that we end up with, or 7 is not a part of that. So if 7 is a part of that, like is included, if it is included, or if is not included. If 7 is included, then we will go towards left till we find 6 other 7s, because that is the only way to include 7. If we want 7 in our final subsequence in our block, then we must find a array which has 6 7s, these 7s 6 times 7 and 7, and then attach this 7 at the end of this one, so that we have a block of size 7 which has 7s as all the elements. Cool, but we do not have this. So if we were to include 7, then answer would be, let's say, negative -1. -1 would represent that there is no possible answer, or we could just say 0. If we do include 7, then the answer would be 0. But if we do not include 7, in that case, we just need to find out what is the best answer in this subsequence, in this subarray. And here, to find the best answer in this subsequence subarray, we just do the same process with this one that we did with 7. With this one, either it is included or is not included. If this one is included, then we need to find towards the left of this one in this array a array of size 0, which does not have any elements, because to make a block which contains 1, we just need a single one, which this one itself is. So if we do include this one, in that case the answer would be 1, which is this element, plus the best answer in this subarray. Or if we do not include, let's say the best answer in the remaining subarray in this part to the left of this one is x. So the answer would be the best answer x from the left plus 1, because we have one extra one, whatever that subsequence is on the left, plus 1. That is our answer if 1 is included. But if 1 is not included, then the answer would just be x. So here it is just like cool to include 1, because our answer is x plus 1 and not x. So pretty good. Hello. Yes, I want to like get good at CP and just be him. Shit. So let's just include this, and since there are times when we want to go left, well, what is unit testing? Shit. I have not written any tests in C, but it is that when you write a function, there are some expectations of the out of the function. For example, if you want to write a function that takes temperature in Celsius and returns temperature in Fahrenheit, then there are some expectations in this function. And if you write this function in C, then unit testing would be like you would write another function. You would call that function like test. And in that function, you would repeatedly call this function with some Celsius temperature whose Fahrenheit values you already know. And let's say you have a list of, let's say you have a 2D list, some value C1 Fahrenheit 1, comma C2 Fahrenheit 2, comma dot 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 dot. And in this test function, what you will do is you would call this function which converts Celsius into Fahrenheit, and you will call it with C1 and compare is this equal to F1. And if it is equal to F1, then your function is working correctly. But if it is not, then you will throw an error, and that would mean that your function has failed the test. So something is wrong. And you would do this with all of these Celsius Fahrenheit values that you have. Shit. Like they made me write a header file that includes that into test.c, then include it into main. Okay, so you had to write a header file which has hash include, and then you include this .h file into your main.c. Okay, that is like fine, cool. Okay, and also back to this here, since we will have to at times go to the left of the current element, which might mess us up, because at some point we will be here and we will be looking left to the first element, which will give us error because there is no element to the left of the first element. So we will have the size of this thing plus 1, and we will start storing elements into this thing from index number 1, right? And cool. For int I equals 1, I smaller than n, I plus plus. Okay, and here we will, it is like pretty cool to write down what answer I means. Answer I means best or longest neat subsequence in array 0 in range a 0 to I, where I is included. So pretty cool. Wait, shit, where I is not included. And when you are currently here, either you go to the left, and what are the time complexities for this thing? 10 power 5. Okay, you cannot do n square, you cannot do n square. You cannot do n square to so you would need a map of integer to integer. MP would be the name. Yep, cool. And include AI. Here you are testing for include AI. If you do include AI, wait. If you do not include AI, then answer for AI would be answer AI minus 1. And then you try to include AI. And when you do, you need to find not just integer, you also need the index here. Where would be okay? Here would be okay. Where MP I would mean first would be the number times seen. Shit. No. You need a stack. A stack. A stack. A stack. A stack. Or vector. I would be list of indices where I has been seen. Good enough. So include I MP I dot pushback AI dot pushback I. Good. Now if you want to include I, we can only include I if the size of this stack, if AI size is equals exactly equals to AI. If the size is exactly equal to AI, a set is better. A set is better because we will be doing a lot of elements, a lot of operations. Yep. Okay. Size exactly is equal to this, then get that smallest index auto it equals mp ai dot begin and if we include, then the answer would be answer till go to it -1 plus ai. If this number is greater than the current answer at this location, then we make our move and we say answer I equals answer go to it -1 plus ai, and also we have to remove this it element, so mp ai dot erase it. Is this this is okay, this is okay, and at the end see out answer dot back with a new line. Cool, looks cool, looks cool. Hello. We include some munit module. So what is munit module? Cn means input in, yep, input. It is a way to take an input. And now I can listen your shit. Let's go. Vector is just their own way of saying an array. Yeah, it is just a array on the heap. Map is a dictionary. Map is a dictionary. Shit, me. Yes. Tell him. Just VM. Tell him. How much do you know? How develop work ethic like you? Wait, should I do not have a work ethic? Ethic, not a good one. Shit, I have. I won't say that I know these programming languages, but I have written code in them. I have written in C++. I have written in C++. Right now, I'm writing in C++. In TypeScript, I have built projects, and I built one TUI in Go, and I did something when I started programming in college in Python, and I guess that is it. Yo, let's go, rusty guy. And yeah, just like for ethics, I would say no matter how you are feeling, just get up and start doing this thing. No, because right now, even today, before starting this stream, I was feeling maybe no, it has been late. Yeah, maybe I should not stream this or that. But yeah, just get up and start coding. Like noob codes. Everyone is a noob. And do not compare yourself to anyone else. That just is very dangerous. Okay, maybe this might work. And also, do not expect your code to work. Look at this, wrong answer. Do not expect your code to work. So apparently the answer is 0 for all the cases, because we are not going till the end. We have to say less than and equal to n. And now the answer is correct. So cool. And since I did this problem way back in August last year, I will also look at the solution that I submitted then and compare it to what I did now, and we'll see which one is better. And I'm afraid that my older solution was better than the one that I did now. We'll see. Code Forces does take up quite some time to load up. Okay. Shit. Shit. What could be wrong? Now, we could either just look at what went wrong here by looking at literally what went wrong, but we are very good programmers, so we will look at the code and we'll try to figure out what could have went wrong. It is not a time complexity issue. Yep, not a out of bounds issue, because the size of the array is within the limits. Like 10 power 5 is very cool to work with. And also, we ignored, or we did not look at this fact that all the elements in A are of size 1 to n, which means could we didn't had the need to use a map here. We could have used a 2D array, because we know the key here is not going to be very big. At max, the index can go up to 10 power 5, which is very within the range. So not a problem there. We could have used a vector, but still using a map should not give wrong answer. It might not be optimal, but wrong answer should not be there. This part we are handling like a pro. Like, yes, what could go wrong in this? AI equals AI minus 1. Nothing wrong with this. And include, if we do include AI, the current element, then we first of all insert AI into our set, and set is just a set, like, yep, what it means, set of integers. And if mpai dot size equals AI, which is the definition for a block, that is yes, there shouldn't be any problem with this part. This looks amazing. And also, instead of auto here, we could say, I think, set of integers iterator, which is the type of IT. Maybe precedence error, like uh, this greater than might be being evaluated later on, but I guess that is not in C++ for plus and this operator precedence. Shit, so plus has a higher precedence, therefore plus is evaluated before and greater than is evaluated later. So this would mean, yep, B plus C would be evaluated first, and so this was not a precedence error. A answer I go to IT minus 1 plus AI. Okay, I don't think anything is wrong. I mean, something is wrong. That is why we are getting the wrong answer. But I don't think anything is wrong here. Oh, I guess we should look at what went wrong here. Yo, yep. I don't worry about mine. It is mostly doesn't have to worry about mine. It shit. Okay, you are familiar with the art. Okay, we got wrong answer on answer 118th. How do we look at that problem statement? Expected 4, found 2. So that might be useful. Expected answer was higher, but we returned an answer that is lower than the correct answer. Could that mean something? Let's do some custom stuff. If we have a array of size 5 and we do 2, 3, 2, 3, 3. Answer is 3, which is correct. We can just remove these 2's and we would be okay. So, 6, 3. Wait. Not even 6. One test case, 7, and 2, 3, 2, 3, 2, 3, 2, 2. Here the answer should be 4. If we just remove all these 3's, we should have 4. Okay, we have a test case in which we are getting a wrong answer. We are getting here the answer as 3 even when the answer is 4, because we can remove all these 3's and we would get the correct answer. But we don't. But we don't. But we don't. Okay, probably because when we are here, we look at the index of this 2. When we are here, we don't have a 2, so we cannot pair it up. When we are here, we can pair it up, and we do pair it up, and we remove this 2, and cool. When we are here, we do pair these 2 up, and if we were to, we would get nothing. But if we don't pair these up, we would get 2 as the answer. A makes so much sense. Okay, so if we just here do not just greater than, but even if equal to, either that equal to, or put this thing here. Good. And now my prediction is that we will get the correct answer. 7, 2, 3, 2, 3, 2, 3, 2. Oh, good. And we can submit this now. Well, it was a small edge case. I should not have messed this up, but I did mess it up. My bad. Hello. Shit, your messages are getting deleted. SB19 gaming. Wait, how do you make the indent lines dim? My new indent lines all are equally bright. in scope or not? No, not an off-topic question. This is a topic question. I'm using in the OM, so it is off-topic. Okay, this thing uh, that I'm inside this indentation, so this line is bright. I think I'm using a plugin for this. I don't know specifically which plugin is doing this, but it is a plugin. Let me check it. These are the plugins. One of them is doing it. Could be LSP Saga or, but not Lua line. Lua line is for this thing at the bottom. It is one of these plugins which is doing this. Indent blank line. Wait, this might be it. This should, I think this is it. This is it. Indent blank line. Lucas Reinecke. Yep, it is this one. Before the line was like this, and now it is like this. So this is the plugin you can use. Cool. Let's go. And let's go. Correct answer. And this is using a lot of memory because we should probably change this to a vector of set where size is n plus 1 is a valid size, and each element is at the start a vector of integer or a set of integers. And we will just like still call this thing a map, and this should probably still work. Yep, it does work. Let's see how much time, or time is fine, but this is taking a lot of memory. Let's see if by using a vector we fix some memory issues. Snacks, shit. You can increase your cholesterol, I think. Okay, I closed the browser. Snacks, yep. Wait. Wait. Shit. Cool. And new snacks. Snacks and we shit. This is also by Folk. This guy, Folk. He made lazy. He also made a new key map. I don't think it is called key map. The thing which shows you all the which key, and the thing which shows you all the key maps which you have defined in your Lua, and who is seasonal contributor. And I think he's also working on a LSP manager, if I'm not wrong. LSP noise. Yeah, he's good. And he made this thing, a collection of small QOL plugins. Great. Quality of life. Let's go. Okay, that is a lot of plugins. Zen plugin. Distraction free coding. Yep. He's cool. Yep, great guy. I can vouch for him. Okay, this did not help us in the memory. This did help us in time, but not in memory. Okay, let's look at the editorial. What do they suggest? This is problem number A. Shit. In the team, if one team problem against the difference. Here, let's look at the code. And from the code, we will try to figure out, like, code is the best depiction of their thoughts. So code is cool. Okay, one difference is that they have defined these things outside the scope of the main function, and they use scanf, which is based. Take an n, fill up q, q type dq of integers, size maximum, max value of n, and qi dot clear. Okay, this is a array, an array of dq, and okay, so they first clear everything from the queue, then they fill up ai, they fill up ai, and then I1 to n dpi equals dpi minus 1, comma. Okay, that is some crazy syntax. How can they use comma? dpi is just an array of integers. How are they using a comma here? And place back is used to put something in queue with this as the arguments to give to the constructor of type q, and q has a dq, so this will create a queue of size I think, but this comma, how can they have a comma in it? Is new C++ syntax. There a comma in the middle of expression. How do we have a comma here? There was a time I used to do CP, like, oh shit, okay, I could not do CP for 10 hours. 10 hours is crazy. Like, 10 hours is crazy. What is your name? Weak as shit. Weakest among the weak. That is a dope name. Cool. Comma operator. That is an operator. The comma operator evaluates both expressions left to right and returns the value of the rightmost. This is equivalent to dpi gets the value of this thing, and okay, shit, okay, why it works here, equal to assignment operator has higher precedence than the comma operator, so this thing runs and then this thing runs as if this second thing was a separate thing on its own, which it is. Okay, cool. So the reason that they are using this comma operator is because they wanted to do two things in the same line, and if they were to use a semicolon in the place of this comma, that would also work. So for example, we could do the same thing here and replace this with a comma, and cool, this thing still works. We could theoretically maybe accept the loop, put all these things on the single line and separate them by a comma, like HTML. Okay, if if we make this share, that is crazy. We can even separate them. Okay. We can even give a new line after this. Cool. And shit. I would also like to do some more experiment with this. C++ insights. This is a cool website. If this is the one, yep, this is the one I'm looking for. Here, if we say int a equals 10, and I think okay, this just breaks the code, the C++ code here, into smaller code, but I thought this might convert this into assembly or C assembly language online converter C++ Explorer. Is this God? Yep, this is the one. This is the one. God block. Yep, this gives. Okay, maybe we don't want to do assembly. Maybe we don't want to do assembly. Comma. Yeah, that shit. I mean, you would know you did 10 hours a day most of the time. But don't do this. Sometimes operator precedence causes problems in inline conditionals. Yep. That is correct. Yeah, I guess we don't want to do assembly. Let's do assembly. If we have a, this thing doesn't return anything. Okay, shit. Okay, stop Vimium here. Vimium was messing stuff up. Void, if we say int a equals 5 and b int b equals 3. This shouldn't be an error, but it is. Shit. Okay, cool. Okay, this compiles to this assembly, and if we change this with a comma, we cannot do this any longer. Okay, okay, fine. Let's try to do some other problem. We did this. I also did this very long ago. What was the time then? Shit, this is taking 4000 KB. Now it is taking 1000 KB. Right. Code forces is slow. It is slow. It was 4000 before. Now it is 17,000. Okay, it was much better before. Vector of integers. Vector. Okay, I didn't use a set. I used a vector. But set is better. Index, IND means index. dot size greater than or equal to this pool. Okay, yes, we can use a vector. If yep, we can use a vector, that would also work. Vector, and we can predefine the size of this vector to be n plus 1. Or we don't have to predefine the size of the vector. We just don't have to erase anything on this vector. Push back I, and if size greater than or equal to, in that case we are looking for index would be mp ai ai mp ai dot size minus ai minus 1. Plus 1. Or nothing. Probably nothing. Yep, plus 0. Yep. And we are looking for answer at index int and answer at index int is that cool, that is cool, and we will submit, and then we will move on to the next problem. It has been 52 minutes on a single one. Declaring b twice. Shit, makes sense, because int a equals something comma b. Makes sense. Declaring b twice. More blow. Yep. It is slower. I used it because I was thinking that we should remove an index from the list after we have used that index, but we don't actually have to do that. And removing an element from a vector was like very uh, bad thing to do, so that's why I used set, but we don't have to remove it. So yeah, well, we don't have to remove anything. In you and set. Shit, of course, shit. Answer IND. No. Oh, yes, answer IND, yes. Answer IND is correct. I think mp ai dot add, yes, add, and here we can use from then get the element at index ai negative, and here we are putting in the index and we are getting back the index. And if we were doing this with something like 1, we would get at c++ dot and -1. Does it return the last element? Shit, out of range. While okay, add is for bound checking, not -1 thing. Yep, I do have to get the size. I thought add can use minus e. Shit. And int ind mp a I bracket sz minus ai. This should be working when if ai is 1, if size is 1, then mpai is a vector of all the indices where we have seen 1, and size -1 in that case would give us the last element, and we do need the last element because that is what we put here, and we are going to include the last element in our final answer. Therefore we need to find the best value in last element -1 index. Okay, that was the problem. Now we are happy. Absolutely. And it was giving the correct answer in test case 1 just by pure chance, coincidence. Shame. Again, we didn't do any problems out of these. This one was cool. This one, 2184. I think we did this one day before yesterday. Codeforce is fastest website. I think in this time we can learn how NixOS works. So we can like legit learn how NixOS works. There are 3 parts to NixOS. There is the language, there is the package manager, and then there is the operating system. And we can continue with this. Cool. Switch off editor. No. Cool. And okay, I guess we must use this much memory. Fine. Yep, DevOps engineer. They do need some DevOps engineer, but also I think it is also their model that anyone can upload anything and they would have to run that code on their server, which is a big load, and also they have a finite amount of memory or money. But still, I think yeah, with better DevOps engineer, they should be able to manage. They are supported by someone on or done. shit, they have $2,000 in their account. Okay, and who was the founder of Code Forces? Yes, Mike Mezanov. He's the guy. Look at his contribution, 192. His contribution is 192. And if you go here, top rated player, okay, tourist is number 2, and top contributor has a contribution of 158. Bro is out of the league. Bro is like in another level, and bro has never solved a problem ever. So yeah, bro is pretty cool. Okay, cherry tree, we did this. After some time, we were able to do this. Cool. Now, if there is some recommended problem that we should do, like if there is some specific problem that you would like to suggest, we can do that, or we can spend 1 more hour solving one of these. Okay, we did this one also, One Night at Freddy's. We had to do a n square algorithm, and the hint was this thing, m into n, so we can have an algorithm which goes m big O of m into l time complexity. And what was this? Swap to rearrange. Okay, we have not done this one. Let's do this. Okay, we will do this like for real, as if we were in a contest. It would be cool. I haven't in CP for 4 months. Shit. Okay, like you can start again, like whenever you get time. Maybe you can stop watching this stupid stream and do some CP. Maybe, I don't know, from CACS. Okay, stopwatch. We will do as if we are tourist. We like legit are tourist. Gennady Korotkovich. Okay, you are given two arrays A and B, both of length n. You can perform the following operation. Choose an index I. We have two arrays A, B, length n. Choose an index I, 1 to n. Swap AI with BI. You can perform the operation any number of times, possibly 0, but each index can be chosen at most once. Your task is to make A rearrangement of B after all the operations, or state that it is impossible. You do not have to minimize the number of operations. Okay. Okay. I am feeling dynamic programming. We have two arrays. A and B. And let's take an example. This one. Wait, shit. We have to output. What do we have to output? In the first line, output the number of operations, and in the second line, output the operations themselves. Cool. Okay. These are 1, 2, 2, 4. We do not want or have to minimize the number of operations. We just want an even split. And all we can do is swap elements at the same index in A and B. So in this case, if there are like there is a 1 somewhere, there is a 2, there is a 3, and there is a 4. So the number of ones in A is 1, and same for the number of ones in B. For 2, there are two 2's in B. So in A, we would like to split them equally. So we would like to put this 2 here or this 2 here, and it would be cool to put this 2 here, because if we were to do the same with this, maybe we might mess up, I don't know. So let's say we swap this, and then we would have 2 4's in this array, because this would become a 4. So we would swap this thing and we would have a 3 here and a 4 here, and it would be cool. We would have a 3, 1, 2, 4, and here also 3, 1, 2, 4. But how do we tell our computer to do this? So we can check for a few checks. First of all, we can go through A and B and count the number of times these elements are appearing. We can have a dictionary where the key would be these numbers and the value would be how many times they are appearing. So yep, 1 is appearing 2 times, 2 is also appearing 2 times, 3 is also appearing 2 times, and 4 is also appearing 2 times. And so first of all, because we want even split, we want A to be a rearrangement of B. It means that if some element X is appearing some xn number of times in A, that element should also appear xn number of times in B. So their count of each element should be even so that we can have an even split. If we had 1 3 times in total, no matter how much we rearrange, we can never split 3 ones equally between two arrays. So cool. So first check is to just see their count of each element that is appearing has to be even. After making that sure, we have to make sure can we equally swap things. I guess we can simulate this. Ten power 6. We can go n log n. And since we have the condition that at most we can do an operation at most only one time. No. Shit, I think yes, we can simulate this. No, we cannot. If we look at a specific element, let's say x, and it is appearing in A, let's say 4 times at 4 different places, and in B it is not appearing at all, then out of, and we are saying that the count of x is 4. So we do know for a fact that out of these 4 x's, 2 of them have to go into B. So which ones? Let's say there is some hypothetical correct solution in which this one and this one have to be in B, but we do not know that. So we randomly simulate the solution and we choose this one by default, like randomly, let's say, or not this. Why would we choose this? We would choose, let's say, this one, because this one appears first before this one has the smallest index. So let's say we choose this one and we put one in this one into B. So cool. Okay, then we need to put one other x into B also. So we choose this one again because this has the next smallest index. Okay, so we have chosen this index once, we have chosen this index once, but since this is not the correct solution, this breaks something up, because in the final solution we need this and this to be in one array, and this B and this to be in the other array, and they don't have to be specifically in like this one and this one don't specifically have to be in A. They can be changed, but they have to be in the same array whatsoever. They can be in B together or together in A. But if we are randomly making our choices and we made this choice early on, this would never work because this breaks other things. Okay, maybe. Okay, this does not help us in anything. Skylar, shit, Walter White. Huh? Stop everybody. Okay, I will not call CP. Cool. Brought back from dead. Mm, okay, like this approach does not work. Uh, I think we have a set of indices from 1 to n. We can divide them into different parts. Some index would be like this. Some indices would be like this, where we would like to do a swap. Are there going to be indices where we do know for a fact that we must swap this I? I don't think so, because if there is some element which is appearing in one array more number of times than it is appearing in the other array, then always we have a choice amongst multiple indices. Yep, we always have a choice among multiple indices. So for each element, we do have a choice. For each element, we have a choice. For this x, we have these four possible indices which we could swap. And yes, maybe. And also, we don't have to look at indices where, let's say, if there is some index I where AI equals BI, we can just ignore this because swapping this like does not even matter. But for all the other ones, this is a cool problem. Here it is. Thinking. It's been 12 minutes. And yep, this is not a dynamic programming problem because we need to know things about the future also, or like towards the right and also towards the left. Mm, yep. 10 power 6, number of elements is 10 power 6. The only case that this would fail apart from if all the elements have an even number of count, the only case that this would fail would be when there is a cycle. Let's try to make a cycle. If A has elements 1, 2, okay, this is like already solved. Shit, so we can ignore these two and we can just solve this and this will work. Shit, can we always divide them? That would be crazy. Second, okay, for this one we cannot divide these. Yep, makes sense. Here we can. Okay, maybe we just, this is the only check that we have to do. That, but this is E in division 2, so the answer might not be this simple. Just checking the count, but let's see. It might actually be this simple. A is also N 0 and B N 0 X and A X for int reference X B and MP or map int MP initialized for int I equals 0, I smaller than n I plus plus MP AI plus plus MP B I plus plus and bool possible equals true, and then for auto nothing, we just need the count in MP if C and T is odd, then possible equals false and break, but otherwise we need to find the correct solution. That is the thing, we need to find the correct solution. We don't just have to say yes or no, we have to find the correct solution. Okay, that is the tricky part, I guess. Yep, otherwise this would have failed. Okay, so we are supposing, we are just assuming that if count of elements is even, then okay. That is what we are assuming. This might be wrong, probably is wrong. Okay. Now, if P, if possible, then else, something else. If, let's say, if not possible, then C out, -1, new line, and Z, -1, yeah, just -1 and new line. And also return. Else, we don't have to explicitly write else because we do return inside this if. Else, we are assuming that in case of else, the answer is there. We now need to find out the right answer. If we have A as 1, 1, and B as 2, 2, we either swap this or we swap this. We swap one of these. But how do you decide which one? Mm, Shit. Yep. I have no idea here, so it is cool to look at the tutorial because I can tell even right now that I don't know what to do in this one. E, E, swap, rearrange. This one, let's see, look at the graph problem. bipartite bipartite graph. This is a bipartite graph. Don't tell me I am very very stupid. D cost of tree. Wait. Wait. Maybe this is the contest. 1081. No, this is not the. If that was other, there was a contest in which I messed up and I was not able to find out the answer, and the answer was a simple bipartite graph problem, and my friend was able to do it, and I was very very sad after the contest. And this is not that one. Shit, Dominator was only able to do two problems. I guess I'm better, but me and my friend, we are better than Dominator. He's Dominator 69. This that. Okay, this we looked at the hint and it said graph problem, and this does is now starting to feel like a bipartite graph problem. Yes. Yes, this is a bipartite graph problem. No, shit, this is not. This could be. Let's see. Yes, this is a bipartite graph problem. Now we are figuring out. Yo, hello. I'm trying to solve this problem in which we have two arrays and we have integers in both of these arrays, and we have to split these integers equally. That is, if there are two ones totally in both the arrays combined, then one must be in one array and the other one must be in the other array. But the constraint is that we can only swap elements at the same index. That is, if we were to choose this index number 2, we would be able to swap these two elements, and 2 would go up and 1 would go down. And in that case, that would split 1 evenly and also 2 evenly, and we can do the same with this index, and that would split 3 and 4 also evenly. So cool. And this is a bipartite graph problem. Now I'm figuring out how to make the node connection. And how are you, Eric? Long time no see. Shit. Weakest among the weakest weeks. Okay. And shit, I guess this should have been obvious that this is a bipartite graph problem. And bipartite graphs are graphs in which the connections are like this, where you start somewhat like this, the connections. I messed this up a bit, but the point is that you can split the whole graph into two groups if your original graph used to look like something like this. Then the point is that you can split this whole graph into two groups, and these groups are such that there is no you can there is no connection between the nodes in the same group, and one node only points to nodes which are in the other group, which is exactly what kind of, not exactly but kind of what we want here, that this one would, well, first of all these elements would have a connection with the opposite elements in the other array, like this. That would be their first connection, and second connection would be one one three three two two four four three, like this, like this, like this. Cool. Is this a bipartite graph? Does not look like one. I mean, we have a kind of cycle here. uh, 1 2 1 2 3 4 4 3, and the connections would be like this one. When this is the one, this one went down, so this is like this now, and there are always connections like this, and this two went up, so this connection is exact, and this is like this. Cool. And these two pairs got swapped, so we have a zigzag connection here. And cool, this is a bipartite graph. This is a bipartite graph. But if there were more of these, like if we had a more complicated one, 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 two, 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 I think we can just connect these like this. All the nodes which, or all the elements which have the same number can be connected directly, which have the same value can be connected directly, but order does matter. Order of the connection cannot be arbitrary. Well, yes, so much fun. Leave this behind and run. Shit, moreover, I have been writing more blogs as well. Yep, you have been writing a lot of blogs, and you can tag everyone. Like, like, I think anyone can tag anyone, and you can tag everyone in the server also when you post about your blogs. That would be cool. You were telling me to tag. You can like tag them. It's cool. Hmm. We would be able to convert this graph into a bipartite graph 1 1 like this, 2 2 2. That is a bipartite graph. But if we were to make the connections like this, then also we would be able to convert this into a bipartite graph. But the final bipartite graph, wait, maybe we won't be able to convert this one. The final bipartite graph is going to be different. Okay, let's try to convert this one. This node needs to go down, so 1 1, and this one can be up, and yep, shit, yep. There should be a circular connection between these, like so, like so. Yep. Maybe bipartite is not the right way to solve this, because it, it is inappropriate to tag everyone as it's in. Yep. It's not polite in some servers. That is why I asked. I mean, yes, you can tag if you want. Like if you think you want to, you can tag. Yep. Shit. Or maybe like, yeah, yes, shit. It could be impolite, inappropriate. Maybe not tag everyone and tag the ones whom, tag the people that you know, and like if there is anyone else who wants to look at it, they can look at it without tagging them. So like you can tag modular, always he is there, modular, Kakashi, Kilua, and Nick, and me. Hmm. Uh, Shit, I guess bipartite graph is not the way to go here. Some other kind of graph, and you can tag Darswai. Shit, you can tag Dars Parikh. Yes, yes, like, yep, yep, yep. You can tag us. One, up, down. This has to be up, and then this must go down. Cool. And then this two must go up because of this one, and this two must go up, and two, and two. But yes, this is not a bipartite graph anymore, even though this is the correct solution. This is a correct solution because the number of twos here in array A is 2, and in array B also we have two twos, and two ones are here, we have two ones here. But according to the connections that we made, this is not a bipartite graph because these two twos are connected to each other and they are on the same side. So this is not a bipartite graph. So I guess bipartite graph is not the right way to go. Some other way. Yep. Because here in bipartite graph, the way that, or maybe we can find a better way of making these connections in nodes. Let's look at one more line of hint. We would be sitting here all day. Solve to rearrange. One was graph problem. What is the most that we can bring out of these two words? Graph problem. Well, we have not said that this is not a graph problem. This is just not a bipartite graph problem, as far as we can say. A general graph problem, graph coloring problem. Essential problem is to divide things into two groups, but the division is not random. The division is not random. If you put this you have to, yes, this like forget everything else. Let's say you have two buckets, bucket A and B, and you have pairs. Shit, this feels like a problem that I've done before. You have pairs like this: 1 2 1 2 1 2 1 2, and you either, when you go pair by pair. Okay, this is like very doable. You go pair by pair and you see how many ones and twos you have in each of these, and yes, you put a one here, then the other part of the pair must go in the other one, and here when you get the second one you put a one here and a two here, because you had lower number of ones here and lower number of twos here, so that is how you went, and then 1 2 and then 1 2. Okay, now can we convert this into a graph problem, or maybe we don't have to convert this? Rating of this, no idea. This is E in division 2, so it is pretty high rated. This was 7 weeks, so I don't think we have a rating for this round. Nope. Probably don't have a rating for this round just yet. Nope. Shit. Yes, because, and also I am using Code Forces helper. Show ratings. Multi-user rating graph. Save questions. Okay. Contest participation checker. And yep, it seems like this question does not have, this problem does not have a rating yet. We are not hiding the rating. Yep, this problem does not have a rating just yet. Okay. Okay, shit, this is a new thing. I do not know about this. Eulerian cycle. Eulerian cycle. Okay. So this is a graph problem, but a different kind of graph. There is Hamiltonian graphs. There are Hamiltonian graphs. I guess Hamiltonian graphs are graphs where you can go from one node to another node. Okay, I don't know. I forgot. Hamilton. Hamiltonian graphs and Hamiltonian cycles. A graph that contains Hamiltonian cycle. Okay, very helpful. Unlike Eulerian graphs. a cycle that visits every vertex exactly once and returns to the starting point. Okay, Hamiltonian graph is a graph where you can start from a specific node and visit all the nodes and then get back to the node there from where you started. Unlike Eulerian graph. In Eulerian, I think that is the pronunciation.
An Eulerian graph.
Eulerian, we will call it Eulerian. And an Eulerian graph is a connected graph containing a circuit that traverses every edge exactly once and returns to the starting point, to the starting edge. Okay, this is a cool graph about different types of graphs. This is Hamiltonian. We can start from this node, go to this, and come back, and we have visited in the process all the nodes. This is also Eulerian because we start from this, go here, 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 and we have visited all the edges. In this one, we can start from here. We can go here, go here, go here, go here, go here, and then here. We have visited all the edges exactly once. So this is Eulerian, but this is not Hamiltonian because we visited this node which is in the middle twice. So non-Hamiltonian. This one is non-Eulerian but Hamiltonian because we cannot visit both the edges in this like center without visiting one of the other edges at the edge twice. Okay, so we do know now what Eulerian graphs mean, but how can we use them here? AB, AB, Eulerian graph, Euler. This is an Eulerian graph. Is this an Eulerian graph? You can start from here, go right, covered. Nope, this is not an Eulerian graph. Okay, I don't get how can we map the concept of Euler's cycle onto this problem. Let's look at this one. Yeah, it is quite big. It is quite big. Let's see. Make a rearrangement of B means the frequency of all the numbers present in array A should be equal to the frequency of all the numbers present in B. For this to be possible, the combined frequency of all the elements in A and B should be even. Yes, that should be even to split them evenly. If at least one number has a combined frequency which is odd, then the answer would be -1, which we are checking for here. If count is odd for any number, then possible is false and we break out. and then if not possible, then return -1 and return. Now, if the answer is not -1, let's see how to perform the operations. Create a graph with n nodes and n directed edges from node AI to BI. Okay, that means 1, let's say, and 4. Should we did mess up? 4. Yes, 4, 4. That's cool. So this, they want us to make a graph between all the nodes from make these edges. Okay, and then the operation swap AI and BI means the direction of edge AI is reversed. Okay, these are directed. Yep, make n directed edges. Okay, so the direction is this. They are all one way. Okay, and swapping means changing the direction of a node. Then, yep, the operation swap AI and BI means the direction of the ith edge is reversed in the graph. This means for each edge, any direction is possible. Hence, we can consider the graph as an undirected graph, which we need to convert to a directed graph. In other words, we need to decide the direction of all the edges. Okay, okay. So now we are converting this in, we are supposing that initially we have a undirected graph, and our final answer would be to figure out the direction of these edges, which give us the correct answer. Okay, still, like, even after reading 2 paragraphs, I have no idea about what we are supposed to do. In the directed graph, the in degree and out degree of node I is actually meant of a node I actually mean the frequency of I in array A and B respectively. In the directed graph, the in degree and out degree of a node I actually means the frequency of I in array A and array B respectively. Like this. Our problem is to make the frequency of each number in array A equal to B, which means to make the in degrees of each node equal to its out degree. Okay, we are cooking. In the directed graph, the in degree and out degree of node I actually means in a directed graph, like the final directed graph. Right now it is undirected. The final directed graph, the in degree and out degree of a node I actually means the frequency of I in array A and B respectively. And what do they mean by and? Are they adding up the frequency of I in A and B, or but they are using the word respectively, so they are not. Our problem is to make the frequency of each number in array A equal to array B. That is the problem, which means to make the in degrees of each node equal to its out degree Since the combined frequency of all the numbers is even, it means it means the degree of each node in the undirected graph is even. Yes, in the undirected graph, the degree of each node is even, and they have implicitly, not explicitly, implicitly said that they are, first of all, making this connection, that is joining the nodes which are opposite to each other at the same index, and they are also joining the nodes, and they are also joining the nodes which, like, shit, like this. They are also joining the uh, nodes which look same, which have the same value. Since the combined frequency of all the numbers is even, it means the degree of each node in the undirected graph is even. This means the graph contains Eulerian cycles. Since the combined frequency of all numbers is even, it means the degree of each node in the undirected graph is even. Yes, we are with the writer till here. But yep, I don't like that they have implicitly stated that we are connecting nodes like this, which have the same value. This means the graph contains an Eulerian cycle. Each connected component can be treated like a separate graph because it is possible that our graph is not a single connected component. Find Eulerian cycles in all these graphs. Keep assigning direction to the edges in the direction used in the Eulerian cycle, and hence accordingly perform the operations. Okay. So the problem turns, or like, can be converted into a problem where we have a undirected graph and we need to convert this into a directed graph so that the final directed graph is a Eulerian graph. But we don't know how to do that. Maybe it might be in CP handbook. Maybe CP handbook is pretty cool. Eulerian paths, let's go. Eulerian paths. This is like the first chapter in this. Okay, and there is a existence, and they give us some algorithm. Yep, they do give us hierarchical algorithm to find Eulerian cycles. Yep. Okay, so what we have to do now is read this algorithm, implement it, and find Eulerian cycles after converting this thing into a graph problem. And okay, so this is using a lot of things. This is using, first of all, the fact that we can convert our problem to a graph problem, which like, which could be obvious after practicing for some time, but initially it is not obvious that even if the problem is not a graph problem, you can convert your problem into a graph problem. So we are using this fact. And second, well, this, first of all, W should be capital, and second is the concept of Eulerian graphs, and a subconcept of finding Eulerian graphs, not this, but converting undirected graphs to Eulerian graph. bad. Okay, okay, okay. So like, cool. This is what we have to do. So cool. Okay, let's like read about this. But before that, yep, we will implement the algorithm on our own after reading this. But I want to understand how are we doing the division of components? Like, how are we dividing this graph up into components? Because we will be running our algorithm after learning it, and we will be implementing it, but on different components. And component simply means that if you have a graph like connected in some way, if you can divide your graph in such a way so that there is no way to reach one node from another nodes, then those nodes are treated in as a different component. And if there is a node, like for this node, like for example, from this node you cannot reach any other node, so this node would be considered one component. And for this node, from this node you can reach this node, and all the other nodes, if there were any other, they would also be treated as a single component. And in this component you have this node from which you can reach this and this. So like, yeah, stuff like this is said to be a component of a graph. So how are we going to divide up the components? Just that, and then we can start building our algorithm. In the directed graph, the in degrees and out degrees of, if now okay, create a graph with n nodes and directed edges. Okay, the operation swap ai and ab means changing the direction of the ith edge. Yep, this means for each edge any direction is possible. Hence we can consider the graph as an undirected graph, which we need to convert to a directed. In other words, we need to decide the direction of all the edges. Yes, like extremely true, and we are with the writer till this point. But then in the directed graph, the in degrees and out degrees of a node I is actually means the frequency of I in array A and array B respectively. Or okay, yes, I just do not understand this sentence. In the directed graph, the in degree and out degree of a node I actually mean the frequency of I. Okay, what we can do now is we can forget about this problem for now, and we can focus a bit more on Eulerian graphs. Like stop the timer, and let's read about Eulerian graphs and implement the algorithm to find an Eulerian graph. Let's see. Eulerian circuits. Yep, cool. So an Eulerian path is the path that goes exactly once through each edge of the graph. For example, the graph this has an Eulerian path from node 2 to 5. If you were to start from 2, shit, and this graph is undirected, we converted that into a directed graph here. We go from 2 to 1 to 4 to 5 to 2 to 3, and then oh shit. Yep, cool. From 2 to 1 to 4 to 5 to 2 to 3 to 5, and we covered all the edges exactly once. Cool. Euler studied Leonard Euler. An Eulerian circuit is an Eulerian path that starts and ends at the same node. For example, this one. We can start from 4, I guess. No, shit. We can start from 1. Or we can start from 4 also. Yep. We can start from 4, go to 1 to 2, 3, 5, 2, and then back to 4. So we started this path from 4 and we went through all the edges and ended back up at 4. So something like this is called an Eulerian circuit, because the start and end point are the same. The existence of Eulerian paths and circuits depends on the degree of the nodes. First, an undirected graph has an Eulerian path exactly when all the edges belong to the same connected component. When all the okay, yes, makes sense. All the edges should belong to the same connected component. The existence of Eulerian path and circuit depends on the degrees. How? The degree of each node is even, or the degree of exactly two nodes is odd, and the degree of all the other nodes is even. Okay, so the degree of each node is even, or at most, if the degree of each node is not even, then exactly two nodes have a degree that is odd. Okay, now that line from the editorial makes more sense. The degree of each node has to be even. The degree of each node has to be even. Makes sense, but we don't know why, but okay. The degree of each node has to be even, or the degree of exactly two nodes is odd and the degree of all the other nodes is even. Not two, but even. In the first case, when degree of each node is even, each Eulerian path is also an Eulerian circuit. In second, the odd degree nodes are the starting and end nodes, okay, of an Eulerian path, which is not an Eulerian circuit. We need to find an Eulerian path, not a Eulerian circuit. Okay. And in this, how did we make the jump that this has to be an Eulerian path, an Eulerian cycle? No. When do we first use the word Euler? Shit. Here in the last paragraph, we use the word Euler first. Euler. Okay, it makes some sense in like subconscious way. For example, in the graph, this nodes 1, 3, and 4 have a degree of 2, and nodes 2 and 5 have a degree of 3. Okay, wait, shit. It has been long enough, like 2 hours. 2 hours is not long, but spending 2 hours on we didn't spend all this time on one problem. We also did one more problem. But yep, I would like to continue tomorrow now. I will come prepared. I will read Eulerian graphs and we will do this problem tomorrow. This one is a cool problem. Swap to rearrange. Cool. And tomorrow we will implement all the Eulerian graphs. It would be cool. Cool. And because now I want to start my second stream in which we will implement CI/CD pipeline for the chess game that I was building. Yep. Cool. And tomorrow in the competitive programming stream, we will implement this algorithm. Here Holzer algorithm. Cool. So that would be it for today. And thanks for being here. Bye.